Good morning, class. We are looking at practice test number 1, covering module 1, chapters 1, 2, 3, and here's chapter 2. Exploring data with tables and graphs. Chapter 2, exploring data with tables and graphs. Number 1, given the frequency table, answer the following questions. The number of classes in the table is. Frequency distribution table summarizes the data into a format that it's easy to understand. This would be the lower limit. This column would be the upper limits. This column would be the frequency. So how many classes? 1, 2, 3, 4, 5 classes. 5 represents the number of statistical age groups defined, in this case, age group. We want to find the class width. The way we find the class width, if we go with a specific class, okay, class number 1, 2, or 3, then we look up the limits, the difference between the two limits, the upper limit minus the lower limit plus 1 unit. And I want to explain the concept of 1 unit. So upper limit, for example, if you use this one, 20 minus lower limit is 11 plus 1. This one would be 30 minus 21 plus 1. The last one, for example, 60 minus 51 plus 1. And they must be identical, and the answer becomes 10. The concept of a 1 unit instead of 1, because depends on how the numbers are given. If the numbers are given in decimal formats, 1 may represent 0.1, 0.01, or if it's in thousands, 1 may represent 1,000. So 1 unit. So that's one way to do that. The second method is to pick any two consecutive groups. For example, this group, and you look at the difference between the lower limits, 21 minus 11, or 30 minus 20, or 41 minus 31, or 60 minus 50. All of them are the same. So for example, if you choose this one, you get to the same answer. So one more time. If you're using the same group, upper limit minus lower limit plus 1 unit. If you use two consecutive ones, just the difference between the consecutive lower or upper limits. The midpoint of the fourth class. Midpoint by definition is the sum of the limits, lower limit plus upper limit divided by 2. So just for the fourth one, add up these two numbers, 41 plus 50, and divide by 2, resulting in 45.5. Midpoint. The lower boundary of the fifth class is, the way the lower boundary is calculated, the midpoint between the upper limit of the previous one and the lower limit of the next class. Because we want the boundary here, we add these two and divide by 2, in other words, the midpoint, which becomes 50.5. And that becomes the upper boundary of the fourth class and lower boundary of the fifth. So 50 plus 51 divided by 2 is 50.5. So the midpoint of the upper limit of fourth class and the lower limit of the fifth class is the boundary, the upper boundary of the fourth class, as well as the lower boundary of the fifth class. It's important to know, as far as the limits are concerned, that means any number starting with 11 and ending with 20 belongs to this group. Same thing here, starting with 21, ending with 30. But when you go with the boundaries, this is 41. It goes all the way to 50.5. That means any number less than 50.5 belongs to that. And then from 50.5 goes to the next one. Upper limit of the first class. In general, these are lower limits. These are upper limits. And for the first class, lower limit is 11. And we are looking for upper limit, which is 20. Goes from 11 to 20. We want the upper limit. The sample size, you go to the frequency and you add them up. By definition, n is the summation of x. This is considered x. 5 plus 6 plus 9 plus 11 plus 4, they add up to 35. That's how we find the sample size. The frequency column, add them up. We're going to continue with the same question. The next one is, what's the relative frequency of the first class? By definition, relative frequency is the frequency of the class divided by the total size, the total sample size. So RF, short for relative frequency, is F, the frequency over N. We have calculated the N from the previous page to be 35. And for the first class, frequency is 5. So 5 over 35, which simplifies to 1 over 7, or 0.1429 or 14.29%. It depends whether they want it as a relative frequency or percent frequency. Now, it's important to understand this is an exact answer, and a fraction must be always simplified. If you go with decimals, you have to put a lot of decimals unless they ask you when and how to round it, and of course, a percentage format in the same manner. If we look at all of them, I wanted to fill up this table. We already have the first two columns. Now we found this one to be 1 over 7. This one becomes 6 over 35, 9 over 35, 11 over 35, 4 over 35. And this is a fractional format, exact answer. If you can simplify the fraction, you must. If they ask you for the decimal format, you can use that. Percentage format becomes percent relative frequency. We recall that the boundaries are the midpoints between the upper limit of one class and the lower limit of the next class. And we calculated one of them. If you recall, this was 50.5. So we can find the rest of them. The way you find the rest of them, there are two ways. You can go through the same process again, or pay attention, we calculated this in the previous page. We also know the class width is 10. So add 10, you get to the next one. From here, subtract 10, you get to this one. And you continue all the way to the end. As long as you have one of them, the difference is precisely the class width. So if you want to find the class width for the limits, upper limit minus lower limit plus 1. But if you have the boundaries, just upper boundary minus lower boundary will do the job. Find the model class and the mode. By definition, I wanted to give you the midpoints as well because I'm going to need it for here. The midpoint, we already calculated one of them for the fourth class. we had done it to be 45.5. And now the rest of them works the same way. So you can add this to divide by 2, add this to divide by 2, and so on and so forth. But if we had 45.5, again, with the fact that the width is 10, just add 10, you get to the next midpoint, subtract 10, you get to the previous one, and so forth. So if you calculate one of them, then the rest of them just add the width. So the same thing happens with the boundaries. It's very simple as long as you know that width, it happens pretty fast. Now, find a model class. What is a model class? Okay. Basically, by definition, the model class is the one with the largest frequency. Which one has the largest frequency? 11 is the largest frequency, the fourth class. So the fourth class with the largest frequency. And what is the mode? We always, so the class is 4 because it has the largest frequency. And the mode is considered its midpoint. The mode is equal to the midpoint, 45.5. The following frequency table describes the speed of drivers ticketed through a 30-mile-per-hour speed zone. Calculate the relative frequencies for all classes. I like to repeat that here. Here's the first one, second, third, fourth, fifth. Okay. The relative frequency by definition is f over n. So first and foremost, we need to calculate n, or summation of x. We have to add 25, 14, 7, 3, and 1. That's by definition becomes 50. So the relative frequency, for example, for this group, the first one would be 25 over 50, or 1/2. 14 over 50, 7 over 50, 3 over 50, 1 over 50. So that would be the relative frequency. And you should simplify what you can. So 25 over 50 simplifies to 1/2. 14 over 50 simplifies to 7 over 25. The rest of them, you keep them intact. What percentage represents the speed of 53 miles per hour or less? So over here, we locate 53. 53 or less, that means 7, 14, 25, those three. 40 to 45, 46 to 49, 50 to 53. All of them are less than 53. So you add them up. That would be the frequency. And then you divide by n. Or you can add up these three numbers. Either way is fine. Cumulative frequency distribution of 53 miles per hour or less refers to the first three classes. So 25 over 50 or 1/2, 14 over 50, so 1/2 or 0.5, 0.28, 0.14, and we get 0.92 again. Add up these numbers, these 1/2, 7 over 25 or 750, and or add up these three numbers and divide by 50. 25 plus 14 plus 7 divided by 50, 46 over 50, or 92%. The reason we're not going to simplify this because they ask for the percentage, so it's easier to just keep it intact. But as a decimal, of course, you have to change it. What are the class boundaries? And you remember the boundaries are the midpoint between the upper limit of one class and the lower limit of another one. Okay. So for example, if we add these two up, divide by 2, we get 45.5. And remember what I told you, if we have the width, we don't have to keep on calculating like that. I hope you recognize the width is 45 minus 42 plus 1, or 46 minus 42, which is 4. Okay, so this is 45.5, so is this one. And the rest of them now, I'm going to subtract first. I hope you understand why it's 4 again. One way to look at it, you can say 46 minus 42 is 4. Okay. Or if you want to look at these two, you can say upper limit minus lower limit 42 plus 1, and it gives you 4. Either way, the class width is 4. So what do? We subtract 4 here, gives us 41.5. We add 4 here, it gives us 49.5, and we continue with that. So it's pretty easy to find the rest of them as long as you calculate only one of them. The following frequency table describes the speeds of drivers ticketed through a 30 miles per hour speed. So we've done that already. Now, the next part, we are continuing with that question. Construct a histogram corresponding to the frequency distribution table. It's important to understand, when you hear histogram, it's important whether it's asking for frequency distribution or percent frequency or relative frequency. They look similar, but there are different numbers that are used here. Now, along the horizontal axis, we use either the boundaries or the midpoints. And since ogive that is coming up uses the boundaries only, we can go with that. But you can use the boundaries, you can use the midpoints. In some cases, even you can use the limits. And so recall we had the boundaries as such. This is from the previous page because we are continuing with this question, everybody. So we found that in the previous page. So along the vertical axis, we put those numbers, 41.5, 45.5, 49.5, all the way to the, so from the very first one to the very last one. And the height, the maximum height is 25 because the vertical axis is the frequency. So from 41.5 to 45.5, you go with 25. The next one from 45.5 to 49.5, you go with 14, and then 7, and so forth. So we have those numbers. Of course, you know, the scale must be proper. So let's say we go all the way to 30, and then it will look something like this. So here's the speed, miles per hour. Here's the frequency. One thing I want to add, if they say find the width from the histogram, if limits are given, the width is calculated as follows, and we do not add 1 as explained before. if when the histogram is given, just the upper limit minus lower limit. That's how they use it in MOM. But you can't do that here, okay? 45 minus 42 plus 1, if you want to find the width. But if it's given in the form of a histogram, because in the case of a histogram, we really should use the boundaries, and so the difference is the width. 45.5 minus 41.5 or 49.5 minus 45.5. That would be 4, which is the width. So we are looking at the same question in essence. The following frequency table describes the speed of the driver's ticket through a 30 miles per hour speed zone. Prepare a cumulative frequency distribution and prepare cumulative relative frequency distribution. So it's important to understand how we go with finding the cumulative. In essence, cumulative means the total from the scratch. So the first class, 42 to 45, remains the same, and it's 25. The next one, all of it, okay, there are two ways to write them. One of them to use the boundaries, one of them use the limits. When we use the limits, it makes more sense in the following manner. All the lower limits would be the lower limit of the first class. So this one doesn't change, but this one changes to 42, 42, 42, 42. And now this one would be from 42 to 49. That means add these two. This one means add these three. So first, the way we write the cumulative, the first column, either they write it with the limits, just the way I explained it here, or if you go with the boundaries, you put less than the upper boundary of the first, less than the upper boundary of the second class, and so forth. So you just wrote, you just write the boundaries. Which boundaries do you write? You write all the boundaries except the lower boundary of the first limit. This is the upper boundary of the first limit, first class. This is the upper boundary of the second class, and so forth. Now, so what is the frequency? The first one doesn't change, it's 25. The next one is 25 plus 14, 39. The next one, you add the 7, so on and so forth. So 25 plus 14, 39. 25 plus 14 plus 7 is 46, so on and so forth. So what happens is, the very last one, this number must be equal to n. If it's not, we've made a mistake. So that would be part A. So this is part A. For part B, for relative frequency, we write this one along with the relative frequency. And relative frequency is what? Frequency divided by total. So this one would be 25 by 50 over 50, 39 over 50, 46 over 50, 49 over 50, 50 over 50. What is important to know when it comes to cumulative relative frequency? The last one must be equal to 1 or 100%. It depends whether we want to write it as a percentage or a decimal. This must always be equal to 1. I'm going to continue with the same question. We want to draw an ogive of the cumulative percentage distribution. So basically, we have the information from the previous page. And we pay attention to what they want. They want percentage distribution. If they want the frequency distribution, you're interested in this one. If they want percentage, you use this one. And I want to write both of them so you decide which one to use. Read very carefully. So along the horizontal axis goes the same boundaries. And over here, if we were using frequencies, we would go all the way to 25 or 30, but we are using percentage, we go to 100, maybe a little bit more than 100. So we have those, okay? And so the very first one, okay, 41.5 corresponds to 0. The next one corresponds to, in this case, the upper boundary of the first class corresponds to the cumulative RF relative frequency. So this one corresponds to 50%. And since this is a percentage between 40 and 60, so it goes here. That's the idea. And the next one, 78%. So 49.5, 78 is close to 80. So we have those points and it looks like that. So again, 41.5 corresponds to 0. 45.5 corresponds to 50. 79.5, 78. 53.5, 92. 57.5, 98. 61.5, the last boundary, the upper boundary of the last class corresponds to 1 or 100%. This must always be that. And you connect them not as a curve, but line segments. These are line segments, everybody. Line. Segments. Those are straight line, okay? Now, what is it good for? Using the ogive, find the percentage of drivers who drove 47 miles per hour or less. So along the horizontal axis, you locate 47 somewhere here, and you go up. When it hits the curve, you come and do the reading from here. So you locate 47, and that's the number. So number 47 is somewhere between 45.5 and 49.5 on the horizontal axis, which corresponds to approximately 60%. Therefore, 60 or 61% of drivers drove 47 miles per hour or less. That's the usage of the ogive. Given the following sample, the sample represents the ages of 40 tenured faculty at CSULB. N equals 40 different ages. Construct a dot plot, construct a stem plot, stem and leaf, sometimes they call it. So what is a dot plot? First, let's remind everybody, as far as the definition, a dot plot is a graphical display of data using dots for relatively small data sets where values fall into a number of discrete values, categories. Data values are plotted as dots along a horizontal scale of values. Equal values will be drawn as stack of dots. So that's a dot plot. So basically, you have a scale and you put the dot corresponding to any number you have. And if it repeats, you stack them up. So the very first thing we do, we are going to write these numbers in order from smallest to largest. So we are going to go with sorted data, ranked data from smallest to largest. The smallest is 32. The largest is 63. We do that. You could do the dot plot without doing that, but when you sort it, it becomes very easy to see how things work out. So the numbers, we go from 32 to 63. So we have a scale that goes properly. For example, if this is 35 here, 40, 45, 50, 55, 60. So 32 should be somewhere here. And for example, just the way you would do that, you start with 32 and you put a dot here. Then you find 37, you put a dot there. You find 39, you put a dot there. You would go with 40, you put a dot there. Same thing for 42, same thing with 43, same thing with 45, same thing with 46. Put a dot, just one dot. But what happens the moment you hit 47, it repeats. So if for example, this is 47, I put 1 and 2 dots. Again, 48 and 49 and 50, we put 1 dot. When we get to 51, we have 2 dots. 52, we have 1. And again, 53. When we get to 53, we have 1, 2, and 3 dots. So we put 3 dots. 54, we have 3 dots. 55, we have 2. 56, we have 2, so on and so forth. So take a look. We have 1 dot for 32 and 37 and 39 and 40 and 42 and 43 and 45 and 46. When we hit 47, notice there are 2 dots. That's why we stack them up, 2 dots. And we continue the same thing, and we can easily read the data either from the table here that is given or from the dot. So clearly, the ages range from 32 to 63 years. Also, there is more tenured faculty at older age. Notice we have more dots here, right? So this is what you notice. This is what you can read from the dot plot. There is more tenured faculty at older ages. All right, given the following sample, okay, that's the same question. Construct the dot plot we did. Now we want to construct a stem plot, also known as stem and leaf plot. So we want to do that, and let's go with the definition of that. So what is a stem plot or stem and leaf plot? Stem plots or stem and leaf plot display the data in order from smallest to largest. A stem plot, like a histogram, is a tool to help you visualize a quantitative data set. The name stem plot is because there is one stem with the largest place value digits to the left and one leaf to the right. We can see the distribution of the data while keeping the original data values. So what do we mean by that? How do we set this up? Well, again, we look at the sorted data. Since we had done it, we're going to use that one. We are going to go from 32 to 63. So the tens digits are 3, 4, 5, all the way to 6. So we use that as stem. So 3, 4, 5, 6, we don't have anymore. And the leaves are the ones digits. So starting with this one, we see 32, so we're going to put a 2 here. We see 37. Next to that, after 2, we're going to put 7. And next to that, we're going to put 9. The next tens would be 4. I see 0, 40, so I put a 0. 42, I put a 2. 43, I put a 3. 45, I put a 5. 6, 7, 7. You have to repeat that. And then 8 and 9. So now we put again 0, 2, 3, 5, 6, 7, 7, 8, 9. Very straightforward. The rest of them in the same manner. If you go with the next one, which is 5, you have to put 0, 1, 1, 2, 3, 3, 3, 4, 4, 4, 5, 5, 6, 6, 7, 8. You have to put all of them all the way to here. So the first one is 50, and you should be able to read. This is 50, this is 51, this is 51, this is 52, and so forth. You should be able to read. This is 40, this is 42, this is 43, this is 45, and so on. And 6, we have 0, 0, 1, 1, 2, 3, 3. 0, 0, 1, 1, 2, 3, 3. And if they give you this table, you should be able to come up with this. If they give you stem and leaf plot, you should be able to come up with this. Again, the ages range from 32 to 63 years. Also, there is more tenured faculty at older ages because we see that the contribution, the distribution is such that we have more with the 5 and 6. So more tenured faculty at older age.